Okay, I Prakhar Tripathi will be giving my presentation on my topic, that is ellipsoid methods. So let's begin then. So ellipsoid method uh, solves the linear programming problems in polynomial time. This method is of enormous theoretical importance because before that we had simplex method, and simplex method solves these problems in exponential times. So certain number of problems give a certain number of uh, optimization problem or give exponential time for simplex method. But this our ellipsoid method proves that these linear programming optimization problems can be solved in polynomial steps. The ellipsoid method works by generating a sequence of ellipsoids whose volume is uniformly decreases at every step, thus including a minimizer of a convex function. Okay, let's move forward. So since we are talking about ellipsoid methods, it's of importance that we first define uh, uh, how ellipsoid are represented and what is the equation of ellipsoid. So here let's denote E as the ellipsoid, and E is a set of vectors in Rn. Rn is the vector space. To define an ellipsoid, we need two things. The first is center Z, and another thing is D. D is the positive definite symmetric matrix. So this is the equation of ellipsoid then becomes x minus z transpose D inverse x minus z less than equal to 1. Now one of the other important uh, ellipsoid is a ball. The ball is an ellipsoid that is centered at z but with radius r. So the equation of the ball then is becomes x minus z transpose x minus z less than or equal to r square. Okay, let's move forward. Now, before beginning the ellipsoid method, and we will first try to understand how intuitively the ellipsoid method works. The first important thing to understand is while solving the constraints in ellipsoid method, we create a polyhedron. The polyhedron is created by the constraints that are given to us. So in this case, the constraints are ax greater than equal to b. So a is the set of constraints. These are the and p is the polyhedron that is created. Now the task of the ellipsoid method is to determine whether the ellipsoid created by the constraint is empty or not. So let's move forward and see how it does, how ellipsoid method works. So as I've said, our task is to determine whether the polyhedron P that is being created with the constraints that are given to us is empty or not. So for determining that here we have created an ellipsoid ET whose center is xt. Now this center xt, two things can happen. The center xt can lie inside the polyhedron or it may not lie inside the polyhedron. If xt lies inside the polyhedron, we have proven that a point lies inside the polyhedron and hence the polyhedron is non-empty. Since that is done, our ellipsoid algorithm can terminate. Okay, now what happens if xt is outside the polyhedron? Then what it means that is since xt is outside the polyhedron, certain constraint has been violated. So p is made, as we know, is the polyhedron that is made by the constraints, and here the line here denotes the constraint that has been violated. Now since this constraint is violated, so we okay, so let's move forward and see what we have to do to overcome this. Now since the constraint has been violated, what we do is we translate the constraint to a newer position. So uh, as you can see, the smaller line here indicates the constraint that has been violated, and the bigger line is the constraint that has been translated. So the translation of the constraint creates a new surface. So and another thing to note here is uh, the polyhedron P, which was originally created, also satisfies the newer constraint that we have created. Now the newer constraint create a half space, as you can see, the half space that has been created, and half space that has been created passes through the center of the original ellipsoid ET, and since it creates a half ellipsoid kind of a structure, so the half space thus created is known as half ellipsoid. Okay, let's move forward. So this grayish area is the half ellipsoid that has been created. Now the next step of the algorithm is to construct an ellipsoid, ET plus 1 in this case, which encompasses all of the half ellipsoid that we have created. So as here we can see, the grayish area is the half ellipsoid, and ET plus 1 encompasses the whole of the half ellipsoid. One of the interesting feature of the ellipsoid ET plus 1 is that the new ellipsoid that has been created is that its volume is just a fraction of the ellipsoid ET, the original ellipsoid. So this is of enormous importance to us, as we will see in the later steps of the algorithm. Now since every time as we move create a new ellipsoid, the volume of the new ellipsoid is just a fraction of the original ellipsoid. Now consider the next step here is the ET plus 1 is the new ellipsoid and XT plus 1 is its center. Now what we have to do is determine whether the polyhedron P contains XT plus 1 or not. So two things can happen. The XT plus 1 can be present inside the polyhedron. If that is so, the algorithm terminates. We have proven that the polyhedron P is non-empty. The second thing is it may not lie inside XT plus may not lie inside the polyhedron. If that happens, the algorithm moves forward, and again a new ellipsoid is created. So this process iteratively continues to occur. So new ellipsoids are created at every step, but whenever the new ellipsoid is created, its volume is just a fraction of the volume of the previous ellipsoid. The another important thing to note is the polyhedron P is non-empty and full dimensional. Since it is non-empty and full dimensional, there is a threshold of the volume of the polyhedron P. That is, the volume of the polyhedron P cannot be lesser than a particular value, or there is a threshold to the value to the volume of the polyhedron. Now, since we keep on creating newer and newer ellipsoid, and whose volume keeps on decreasing, there would happen there would come a time where the volume of the ellipsoid becomes so small that it bypasses the threshold of the volume of polyhedron P. What it means is iteratively we keep on creating new ellipsoid, and at one instance that will happen is the volume of the newly created ellipsoid is smaller than the threshold volume of the polyhedron. If that happens, we have proven that the polyhedron P is empty, and if before the volume of the ellipsoid passes the threshold, we have found any point center point xt of the ellipsoid that lies inside the polyhedron, we have proven that the polyhedron is non-empty. So this is how the ellipsoid method works, by iteratively creating multiple ellipsoids and then proving that. Okay, let's move forward. As we have seen that at each step of the ellipsoid method we create a new ellipsoid. Okay, so the newer ellipsoid that has been created must encompass the half space H. The half space H is created by, as we have seen, by translating the constraint that is being violated by the center xt of the ellipsoid. So H here is the half space. Now to create an define an ellipsoid, we need two things, that is Z and D. So the newer ellipsoid that has to be created, its name is E bar, we need Z bar and D bar. So these z bar and d bar can be calculated using these formulas. Once z bar and d bar have been calculated, uh, what we see is that the newer ellipsoid that has been created encompasses the half space H. The second thing that we see is the volume E bar of the newer created ellipsoid is just a fraction of the original ellipsoid E. Okay, let's move forward. Now, this is the very important stuff. This is the feasibility problem. The feasibility problem is given a polyhedron that is being created using the constraints that are given to us to find whether uh, uh, there exists a feasible solution that resides inside the polyhedron, or there exists a solution to the constraints that are given to us. So these are the constraint ax greater than equal to b. These are the constraint given to us, and we have to prove that whether any point resides inside this constraint, any feasible point. So for what we do for solving it, we have to create the polyhedron using the ellipsoid method. We create the polyhedron P represents all the constraints that are given to us. Okay, so this is the description of the ellipsoid method that we will use to solve the feasibility problem. The ellipsoid method here, the important thing is we take the input matrix A, and use matrix A contains all the constraints, and using those constraints we create the polyhedron P. Now V is a number that we have taken, and what we do is we we prove that the volume of P is greater than equal to V. So we take a number V and initialize the ellipsoid. So we have to have an initial ellipsoid to solve the ellipsoid method. So E naught will be the initial ellipsoid which has center x naught and and a radius r square L. So this is the equation of a ball, as I have already told in the beginning. So this is the ellipsoid that is being created, and this is taken as the input. Now the output of the ellipsoid method is whether there is a feasible point x star that resides inside the polyhedron or not, or to prove that the polyhedron P is empty or non-empty. So let's see, this is our algorithm. So we initialize the ellipsoid E naught and T star with the following values. Now this is the iteration step. The first step is we first check whether the polyhedron P is empty or not. So we can check by two ways. First is checking if the threshold is reached or not. If it's reached, the P is empty. The second thing is to check whether the center that has been created resides inside the polyhedron or not. If it's so, then P is non-empty and the algorithm terminates. What happens if the center of the ellipsoid that has been created does not reside inside the polyhedron? We do translation of the constraint and create half space. So HT is the half space that has been created, and using we create, and now the next step is to create a new ellipsoid ET plus 1 that contains the half space HT. The volume of the newly created ellipsoid ET plus 1 is just a fraction of the ellipsoid E. Now this is the iteration step, and this steps keeps on happening until either we reach the threshold or we find a point that is inside the polyhedron. Either way, we prove that whether there is a feasible solution to the problem or not. Okay, so this finishes the ellipsoid method, and so in the presentation we have seen how the ellipsoid method works, what are the different steps, what is the implementation, and we have used the ellipsoid method to solve the feasibility problem. Okay, that's it. Thank you.